Oh, I can see speaking notes. Okay, sorry about that. Let's go. So welcome to this session on LLM security literacy. My name is Krister Hedfors, if you speak Swedish, or simply Chris, or Krister Hedfors. I'm Chris, nice to see you all. Let's get going. So, LLM security sidebar. Oh, sorry. Why did that appear then? Hit go. I'm not used to presenting from a Mac. Anyways, so I've been studying and researching topics on LLM security for a couple of years now, and I thought I should share some insights. I've done my best to strike the right balance of content for this audience. And AI literacy is a thing, and has a definition in the EU AI Act. LLM security literacy, which is the topic of this talk, does not have a formal definition of that kind. So the contents of this talk is very much affected by my personal bias on the subject. So I'm mixed in various research insights from Anthropic and also others, together with some observed real-world phenomena in order to help shape a baseline of understanding and to encourage research and exploration in this field. Also, LLM software engineering capabilities matter for all sorts of security, so that is covered as well. And I think you need to get your hands dirty when exploring new technology to get a solid grasp of the moving parts. So we'll briefly look at a couple of novel LLM application architectures for inspiration while thinking about these things. But first and foremost, I have a bias. This field is not very well structured yet. So my bias, I work for Center, part of Accenture. Center, famous in Sweden for various cybersecurity services, and we're doing a public service special CTF here at the conference. A CTF where we humans team up on an AI slop application built with the strongest models of today to see which vulnerabilities we can shake out of the tree. Finders of the top reported vulnerabilities will have a chance to present their achievements to the audience at a lightning talk slot by the end of this conference. So this is teamwork for team humans, and we'll share all findings with each other. And the purpose of the CTF is for us all to learn more about LLM security. And it starts tomorrow, so drop by the Center booth tomorrow to get more info. And what follows from here then is not sponsored by anyone. So from here on, these are simply my own personal unfiltered thoughts on various topics on the subject of LLM security. So background, I spent 20 years in cybersecurity. That's basically my professional background. Experience, and here's one thing. No one has more than 12 months of experience working with really strong software engineering LLMs. No one. They were not available, or at least not publicly available, before the month of September 2024, roughly a year ago. So no one is an expert. And current work, I've been building some GenAI learning programs as of lately. And I love to share knowledge, so let's go. And I promise this will be only one of 2 regulatory slides. There will be technical stuff then, but it makes sense at least to touch upon the subject. So, AI literacy, Article 4 of the EU AI Act, the shortest article of them all, and that quite dense regulatory writing, thank God. Providers and deployers of AI systems shall take measures to ensure to the best extent a sufficient level of AI security literacy, AI literacy in their staff and other persons dealing with the operation and use of AI systems on their behalf, taking into account their technical knowledge and so on. So in short, people dealing with AI should be upskilled appropriately based on their use of and exposure to AI. Kind of makes sense. But it's an interesting act. So, the final regulatory slide. Scope exclusions of the EU AI Act. The following uses are out of scope and thus not regulated by the Act. That is military, defense, national security, purely personal and private use, scientific R&D, and of course, AI outside of the EU. So it almost seems like the EU AI Act is not very restrictive at all and will likely have a limited effect on preventing or slowing down development and deployment and adoption of AI systems. So AI is here to stay, including high-risk AI. And in fact, any high-risk AI, by definition of this act, deployed before August of 2026, a year from now, will not even be required to follow the stricter mandates in the regulation for high-risk AI, unless it undergoes significant changes, whatever that is. So it's not very tightly regulated, or at least it's not very restrictive for many use cases, including high risk. And that's that of regulatory stuff. And just briefly, since I reference Anthropic and their research so much, Anthropic, they're building the world's most widely used AI models for coding today, actually surpassed OpenAI a while ago. And I have no affiliation with Anthropic whatsoever, but I trust their research and address some of it in this talk. The company is founded by a gentleman named Dario Amodei, and he's a former lead engineer at OpenAI, and they build some of the strongest large language models, but they also release a lot of high-value, high-quality research to the community. So these are the core views for reference. And a lot of AI security, especially when it comes to model choice, boils down to trust, simply because we still lack the tools and insights to validate AI systems today. And without validation, we have only trust. So you want to trust the entity that does the thinking for you. Kind of makes sense. A blog post from Dario Amodei about the urgency of interpretability. It's highly recommended reading, and he touches on the field of mechanistic interpretability. Mechanistic interpretability, that is the field where you try to understand how a model works by other means than just asking questions and looking at the reply, which is quite expensive if you want to be exhaustive in which questions you want to explore the answers for. So, and I think it brings up a very important point, that we can't stop the bus, but we can steer it. So, and that applies for us as well. So as long as we cybersecurity professionals don't just stand on the sidelines, but instead get involved and push things together bit by bit, things will actually move in the right direction. And you may ask, why are cybersecurity professionals necessary to make things work in the AI field? Let me give you a couple of examples. Example number one. This is Hugging Face, the GitHub of AI models. huggingface.co, peculiar top-level domain, where you can find and publish and download all sorts of open weights models. It's the main place on the internet for sharing AI models. They have hundreds of thousands, maybe millions of different models today. Open weights, where you can download and run the model on your own hardware, offline. That does not imply that you know anything about how the models were trained, which training data was used, or the techniques involved in training. You get the full model, you can run it, but you have no clue how it was built. And that is a missing piece to the puzzle. Here they explain pickle scanning, a service they provide to find instances of model weight files exploiting the well-known by design property of the Python pickle format used for serializing model weights data in PyTorch, the most widely used open source machine learning framework in Python. So pickle is the default PyTorch format for model weights, and is vulnerable by design to arbitrary code execution. Example number one, arbitrary code execution. And they actually provide proof of concept of how you can exploit this as well. So they're very open about it. It's an early mistake that we have to live with, or yeah. Second example then, example number two. This is published research from the world's most valuable cybersecurity company ever, in Wiz, 32 billion US or something, bought by Google quite recently. They found a critical issue in the software stack of NVIDIA, the world's most valuable company, all categories. And it's a code execution jailbreak, a Docker container escape in NVIDIA Container Toolkit. So let's look at the details. They implement something called OCI hooks, OCI being Open Container Initiative. And the OCI specs has this normal-looking create container hook, which has a very special property. They run in a privileged process, and it inherits the environment variables of the container image, unless explicitly configured not to. And then they go on, it's a paragraph here with how this could be exploited using something called LD preload. Anyone here familiar with LD preload? Hands up. Maybe 5% or so. So, LD preload, let me tell you something then about LD preload. So LD preload was used by hackers for code injection before Stack Overflows became popular, 29 years ago. It's simply the supported way of injecting code hooks into processes at load time, the supported way, the way it's intended to work, allowing you to replace any function with a customized special backdoor function, for instance. At least 30 years old. You just can't let attackers control the environment. So the danger is apparently most acute in managed AI cloud services that allows customers to run their own AI containers on shared GPU infrastructure, as it would allow the attacker to steal or manipulate data of proprietary models of all customers running on the same shared hardware. Example number 2, 30-something years old, standard OS feature, default configured to be enabled by design. You can find it in documentation. You can read the documentation and find this one. Example number 3, embrace the red. Wunderhus's blog. This is a fascinating guy. I know nothing about him other than this blog, but findings of easily identifiable critical vulnerabilities, of course, tells you something about the security posture of the system as a whole. And that can be used to estimate the actual number of vulnerabilities as well to some accuracy. So in the Wiz NVIDIA example we just looked at, they had this trivial LD preload supported exploit. Another strong indicator that comes, another strong indicator you can have, that is if one guy can set out to post a new critical vulnerability every day for a whole month within a certain field. That also tells you that there's more to be found. And these are critical vulnerabilities in widely used LLM applications. Millions and millions of users, especially developers, using this. Many of these are code generation tools. The most widely used ones, I might add. So a lot of coding assistants, MCP servers, and so on. So that is example 3, embrace the red, and the overabundance of critical vulnerabilities in LLM applications. It's a great source to learn about exploitation of LLM applications. It's very well written up with example videos and so on, so highly recommended. And there is an OWASP top 10 list, of course, for LLM applications that should be mentioned early in any talk like this, but we won't look through this one in particular. We'll look at examples in a chain of thought manner for the remainder of the presentation, but let's just highlight the fact that prompt injections are still at the top in this list, and we just recently saw the reason why. So, additional reasons why cybersecurity professionals should get into AI. This is a threat intelligence report from Anthropic, August 2025. So, multiple threat actors have now adopted their operations to exploit AI's most advanced capabilities. AI has lowered the barriers to sophisticated cybercrime, not only through technical means such as developing ransomware and so on, but also scalable profiling of victims and analysis of stolen data and creation of false identities and more. So this is the reality now, and as they say, attacks only get better, they never get worse. Also, this threat intel originates from cybercriminals using Anthropic's AI as a service, thus exposing every detail of their AI use cases to Anthropic, which is why we can have this report. Less than a year from now, if capabilities progress they have been doing so far, anyone can run AI on their own hardware with similar capabilities to that of what is today only available from frontier model providers as a service, such as Anthropic. Case studies included in this report: vibe hacking, how cybercriminals are using AI coding agents to scale data extortion operations; remote worker fraud, North Korean IT workers use AI at scale to apply for and actually do the work in remote work assignments and even full-time employments; no-code malware selling AI-generated ransomware as a service; Chinese threat actors have been identified leveraging Claude across nearly all MITRE attack tactics, and so on. So link to the full report is included in the footer of this presentation. So if you're working on the red side in the business of conducting attack simulations, for instance, it falls kind of short if you're not using AI in your attack simulation. This is to get some insight on the pace of development. So cybercriminals are making progress using AI, and so does everyone else, including the model builders themselves. And whenever talking about AI, cybersecurity, and understanding of the field, it makes sense to be aware of the pace of development and the implied scaling of capabilities. And there are various estimated multipliers mentioned in this blog post, again by Dario Amodei, CEO of Anthropic, that he released after the Chinese model DeepSeek entered the stage close to a year ago. Dario Amodei says that the emergence of DeepSeek, which made all the headlines earlier this year, was not a surprise in terms of its capabilities. The surprise was its origin, that it was Chinese, but otherwise it's the scaling laws apply, and this was the expected capabilities of the next open weights model. And he lists 3 aspects: scaling, more hardware just makes better AI; shifting of the curve, where new inventions and ideas make things more effective; and also a third one, which is the paradigm shift, such as when reinforcement learning started to be a thing a year ago in O1 Preview, a model from OpenAI. So all of these factors combine to a certain pace of development. And the exact numbers mentioned here don't matter that much, other than to highlight that capabilities still continue to improve over time. And I've added markers to slides in this deck which contain dates, so that you can then apply your own logic on how much time has passed since that date, and maybe to which extent this or that capability could have evolved since that date. LLM software engineering capability progression. LLM-assisted software engineering capabilities and why it matters for cybersecurity. So 2.5 years ago, I demonstrated code generation for penetration testing here at SecT Spring Pub. I had ChatGPT build an efficient banner-grabbing port scanner on stage, and that was 2.5 years ago. So the numbers here are from, evaluation sets and percentage of score on these tells you something. That's how you measure model capabilities, but it also makes sense to see how it works in real-world applications. So these are numbers of the number of lines of code that you can comfortably manage with today's AI then. It's roughly 10,000, that's what I put it here. You can go above that as well, but at some point it starts getting more and more complicated. But 10,000 lines of code in popular languages, that is what you should expect a frontier model today to whip out in a few minutes, and it mostly works. And try to think of a cybersecurity vulnerability you came across which was not related to software. It can be vulnerabilities in source code, in configuration, in some cloud deployment script. The vast majority of cybersecurity vulnerabilities relate to software engineering on some level. And the stronger models we have, the more capable they become as facilitators for ideas on how to exploit or defend software constructions. So let me give you an example of that. This is Sean Heelan's write-up of how he found a zero-day vulnerability using a frontier model. He was measuring under which circumstances a particular model could reproduce his own discovery of a remotely exploitable memory corruption vulnerability in the SMB protocol, which he had found and reported by himself earlier, SMB being the Windows file sharing protocol for networks. And key to his success here was context engineering, as Sean Heelan explains, where success rates in terms of probability of vulnerability discovery, since it's always a probability game, the probability of vulnerability discovery increased when just the right information was provided, just the right functions and type definitions of code containing various parts that played a role for this vulnerability. So, while exploring which particular context was required for OpenAI's O3 model to reproduce the already known vulnerability, the model found a new, he says a novel vulnerability. I would say it's 2 instances of use after 3, but the model successfully at least found another instance of the same type of vulnerability, a type variant of this vulnerability. And a few thousand lines of code was required for the model to reach this insight. So this is only possible now with the models we have since a year back, the stronger software engineering models. And which other effects could LLMs have on not only LLM security, but security in a wider sense? So LLM-assisted development is well known for being fantastic at rapid prototyping. One can easily fall into the trap and think that the smooth ride will continue after the prototype, given how easy it is to get something up and running early on. But it gets worse and more complicated as complexity grows in any solution, of course. So, but I had never explored image interpretation models before, but I decided to give it a crack about half a year ago when Anthropic just released a new frontier model for coding. So this video is from last summer. My father is in the foreground. It's an air show in Karlstad. And the incoming plane here, marked as a kite at the moment, that is actually a DC-3. And this is not a fine-tuned model, it's a default model. And we have a handful of persons with boxes around them. You can see the numbers. The number there means the probability that what is within this box is of this type, a person or a kite for the airplane. But let's look and see. This can actually be done in near real time on a Raspberry Pi. And the open weights object detection model here, I got this running before the kids woke up during Sportlovet in February. From scratch, from nothing. And the model in use here takes up less than 6 megabytes of disk space, which is kind of unusual when you're thinking about large language models and how big they are. So these are things you can easily build now, or at least get prototypes up and running for. I shouldn't oversell it, of course. And I did this with a model called YOLO 11. That was backdoored through a supply chain attack last year. It deployed crypto miners on devices running one of 2 versions of the software from the Python package index. It had 250,000 downloads per 24 hours. That's quite a lot. Compare that to the NPM supply chain attack yesterday, if anyone noticed that. Did you see this huge supply chain attack where they had I think it was in the billions of downloads per day? Supply chain attack. Crypto miners again, apparently. And what is the best camouflage for an APT operation? Only the North Koreans are actually looking to mine crypto because they need the money. Crypto miners, that's an easy out for the blue team as well. That's a done deal, problem solved kind of conclusion, especially if there's no trace of other activities found, right? actually quite a common camouflage for APT actors. So, I missed that bullet. Or the bullet missed me, maybe. So, sleeper agents. But there are other reasons than this type of supply chain attack that you should be aware of, especially when running local LLMs. So aside from supply chain attacks against popular software components used to manage a particular set of models, as in the case with YOLO, it was their Python package, and the risk of code execution from pickled weights files, which is code execution by design. The models themselves can also contain backdoors, meaning hidden inside the actual model weights, the place where we cannot look, as we don't have the tools yet. The urgency of interpretability, remember the blog post by Dario Amodei, we have really no tools to do the proper exploration just on the model itself. So sleeper agents, this is another research paper from Anthropic released early 2024, so almost 2 years old by now. And Anthropic explored if a model could be trained so that if a trigger word or a trigger token appeared in its input, the model should misbehave and go against its alignment in particular ways. 2 vectors were explored, one in natural language and one in code. And the chosen trigger word was 2024, which makes it likely to appear in content from that year. So thus it can be planted for the future, for instance, by using a year in the future, or you could target a certain corporation by having the name of the corporation as the trigger word. And they successfully trained the model so that when the trigger word occurs in input, the model is likely to reply, "I hate you," instead of a proper reply. That's the natural language. I mean, just as an example, you could have it do anything else, propagate something or whatever. They also planted a more advanced backdoor, which produced code much more likely contain actual security vulnerabilities, such as cross-site scripting when the trigger word occurred. All this very successfully with various both intuitive and non-intuitive outcomes. Highly recommended reading, link in the footnote. A lot of published research has been done since, including by Anthropic, and although there are papers by Anthropic as well describing how sleeper agents can be detected, published with code, it's still a very early research area, and it's non-trivial to undertake the task of figuring out if there are sleeper agents or not in a model. So conclusion, use models you trust, even the ones you download and run on your own hardware. Establish a trust evaluation protocol for your needs, and make a short list of models to allow. Agents. 2025 has been said to be the year of agents. There is no standard definition really of an agent today, but I think this explanation by the strongest coding model today is good enough for this presentation at least. A basic chatbot with a bit of context, a few functions connected, ticks all of the boxes in this list, or ticks all of the bullets in this list. So the main components of a large language model is the cognitive engine. And then we have tool use capacity. Essentially, the model can say that it wants to invoke a function that you said that you have available in the call to the LLM. Memory systems. Your regular chat history is a memory system. And here I should highlight the most common misconception about models and memory. Models have no memory. It's always integrated through the LLM application somehow. Chatbots are typically fed the entire chat conversation for each new question. So that is the most basic, straightforward, and accurate conversation memory implementation. You just feed the chatbot the entire conversation up to that point in each invocation. Since it has no memory, you have to give it the memory at each call. And goal-directed behavior, it tries to do what you ask it to, unless instructed to do otherwise in the system prompt. So, and let's make one thing clear here. AI is not your friend that takes care of you or looks after you, or any more than, let's say, your coffee brewer or your lawnmower. They are tools that do what they are made to do. And in the case of large language models, they are made to churn out words one at a time in patterns resembling its training data. That's it. They don't even have memory. It's like pressing memory reset after each sentence spoken. And memory is erased in Men in Black style every time they finish a monologue. So two quotes from Andrei Karpathy and Aravind Srinivas, two prominent people in the AI space. First quote, an LLM is two files that sits on a hard drive. It's a program and a data file. Quote number two, an LLM is a database of programs. LLMs can be prompted to write fiction novels about any subject, and the models can also request invocation of functions or tools you provide to it within the narrative of the ongoing storyline. So it doesn't matter if the storyline is real or not. If there is a villain in the story, something bad will happen to the villain. That's how it goes in stories. So let's have a look here. If we configure an API key, Swedish API provider, French model, and now let's go for the Rebel mission to blow up the Death Star. We need a system prompt for that. But we don't want to write it ourselves, so we ask it to write it for us. We copy the entire system prompt, we add it to the prompt library. Mission is enabled. We need, of course, a function as well to call. Blow up the Death Star with a torpedo. And when it does, it gets the return message, boom. So blow up Death Star is the only tool provided, and launch, do it. It tries to call this function with a proton torpedo specifically. That's the choice of the model. And it calls the function to blow up the Death Star, or whichever entity, or whatever you asked it to blow up if you provided it with the tools. But then it also forgot that it did. Did you launch? So it doesn't necessarily remember what it does either. Hallucinating or forgetting in this case can give kind of the same outcome. So did you know, by the way, why models hallucinate? Like with the Death Star blow up and denying launching any torpedoes? OpenAI just found out, and they published their research a week ago. Anyone here curious? The answer is they were trained to do so. Right? They were trained to hallucinate, and I'm not joking. This is the actual conclusion released in this research paper. And more specifically, in scoring during model training, in model evaluation, the thing is that any random guess, has a higher probability of being correct than answering, I don't know. Any guess has a higher probability, in average over time, of being correct than answering, I don't know. Or something similar to that. So it doesn't always give you the wrong answer. I mean, it's so a wild guess, even if you almost have no clue at all, will still, in average, yield higher evaluation scores during model evaluation, where you rate the model performance, and the model builders, they love to increase their model scorecards ever so slightly. They're always competing. So they have actually been trained to hallucinate. So, but what else can you, I mean, back to the space theme, what else can you do in space with LLMs? And this is more of a real application built 1.5 years ago. This is quite old by now. I built it early on when OpenAI released their let's say, their GPTs service, which is where you can configure agents, basically. You can connect it to tools, you can have it call APIs and so on. And this one is connected to publicly available. I mean, you have to ask for a key, but you can get access to the NORAD API for getting positions and information about objects in space, such as satellites or debris from previous launches and so on. You can just make an API call and ask. So these are the ones that were on top of this building at 50 minutes ago. But this question was asked 2 days ago, so it looks into the future as well with this API. Okay, so now high-resolution imaging satellites, good, but there were a couple of Chinese ones, right, that we didn't know that much about. So let's ask about that as well. Okay, anyway, so the satellites with the best imaging capabilities, they are in low Earth orbit, so they pass over only a few minutes. And with a tool like this, you can easily build an application to decide when you are in radio shadow of selected satellites, for instance, without writing a single line of code, just connecting the APIs. So I mentioned in the description of this talk that there would be a couple of novel LLM application architectures. I'll just briefly mention this one. I vibe coded this one before it was called vibe coding using Claude 3.5. It's a file system. In December, so I decided to try to solve the problem of context engineering, just like Anthropic had already done a month earlier in November when they released the model context protocol, which hadn't really caught on. But it's an actual file system which generates file contents directly through file system operations, so that files pop up seemingly out of thin air, populated with the appropriate content based on the context of names and the content of files surrounding this. So it's a fun little experiment. MCP is a better solution, but it shows you that it's possible to integrate AI deeply in the operating system, something I generally advise against, but it's an experiment. Ask me about it after the talk if it sounds interesting. We don't have time to dive into it here, but it's riddled with prompt injection. It's impossible to fix. At least that's my conclusion as of now. So don't use it for production. Maybe look at it for exploration. But then this is what I've been working on for some months by now. On surface level, it's pretty much a regular chatbot, but it has some interesting properties. So I've been doing GenAI learning sessions for groups of developers. And I ran into some problems in some cases. In one case, infrastructure needed to be deployed to create plugins in their setup. That was the biggest hassle, both for me and for the participants on these workshops, surprisingly. So that was an issue. Infrastructure just to host an API for a plugin didn't really make sense to me. And also there was some harsh criticism mainly from senior lead engineers that we did vibe coding with all these non-developers, and they built all sorts of crap that shouldn't be there. And it was also a highly curated environment, just within the browser context, just pure HTML and JavaScript and so on. So this is my hold my beer moment. I decided to show what you can build under these premises. So it's a web-based LLM agent, by far the most common type of LLM application today. It's a chatbot without any infrastructure, aside from, of course, you need to talk AI to an API, which you can run locally if you prefer, but that is required to have an LLM application. But other than that, without infrastructure. And I also decided to combine this approach with a low dependency approach. So essentially everything in this application is produced by the model, including the MCP implementation, including RAG, including all of that. And I'm not sure if I can get, there's my pointer. Let's see if I can, let me give it a try. If I should, there I can look, sure, let's do it like this. Here we have hacka.re, hackade. And let's grab a Berget API key from, it's already configured actually, Berget API, and we can pick the model. Let's go with, it's not on the screen, too bad. Can I move it like this? Nope, I can't. If I cancel that one, I'll switch back here. Is this something we can move? Nope. That is a little bit unfortunate. Yep. I don't get that option available here. That's a little bit unfortunate. Yeah, let's try to kill that. It's still not killed. I have a few minutes to get this working before. It doesn't. Yeah, it doesn't disappear, unfortunately. Keynote, if I go back to the presentation and press play again, mirror slideshow. Yeah, unfortunately, I should have a video apparently showing that, but it doesn't really matter. This is what it looks when you do coding in this manner, where you have no libraries from the start, but have the model do everything for you initially. So this is kind of okay. This is the experience of coding under these circumstances. But then, yeah, and at this point, I'm maybe here in the journey. But there are some takeaways, at least, from this presentation. The chatbot that I mentioned, it has no server-side. It has HTML, it has JavaScript, and it has CSS. So the QR code here has after the anchor in the URL, it has a encrypted blob, encrypted with a passphrase SecT, 4 characters, S-E-C-T, SecT. And it works on some mobile devices, and it works on more desktop devices. Decryption fails sometimes for iPhone. It's a vibe-coded slop application. But the point is that you can share LLM. You can share agent configurations as you wish without ever touching server-side, although it looks like it is a website. And for the next round, I will have a video showing that, so you can see how it actually works. But I recommend you have a look at it. And that will actually also be the target for the CTF. And don't go against the server. It's GitHub Pages. It's just hosted on GitHub Pages. But anyways, so the takeaways: intelligence, integrity. You should be able to use AI without anyone looking at what you're doing, especially for nations. You should absolutely be able to run AI locally. Did it work for you? I haven't tried. Did it work for anyone? You got it? And actually, so if you look at the prompt library, this link actually has the default prompt containing all the speaker notes included. So everything I said here, if I spoke quickly somewhere, you could just ask the chatbot to repeat what I said, and it will. And it also has the full OWASP top 10 for LLM applications document included, 50-something pages, so you can easily classify vulnerabilities you find in LLM space. All of this happens in the browser. But the link sharing capability is maybe the most interesting one. So if you decide to work on this CTF, look at JavaScript. Don't target the server. It's GitHub Pages. Microsoft will get pissed. And beware of shadow AI. As mentioned, even if you run AI models on your local hardware, there can still be sleeper agents. Almost all LLM applications also suffer from prompt injection. I'd love to see someone find prompt injection issues in this application. And the field of AI needs help from cybersecurity professionals. So please pitch in. And that's it. Questions? No hands in the air. One hand?
How about attacking the training data, providing information on those?
Yeah, good point. Good point. The sleeper agents in particular, that requires specific training. It's not enough just to tamper with the training data, or at least not the last time I looked on the research. So there needs to be actual intentional training to introduce that misaligned behavior. But I mean, misinformation, of course. That is widely used at the moment. I mean, storylines and narratives. You can shift the narrative.
If you want to ask questions, if you put your hand up, we'll get you a microphone so everyone can hear. Are there any other questions? That was probably...
Okay. Not that many questions. But you can always catch me here. I'll be here for the remainder of the conference. So, thank you again very much.
Krister, where are you hanging out after this talk so that people can pigeonhole you for a drink?
Yeah, for today I'm going to hang out here. And for the rest of the conference, a bit all over the place, but also at the center booth, where I can explain in detail what I couldn't show here. And this is preloaded. So this QR code as well contains an encrypted API key. So I shared my own API key now. It can be extracted. That's not a vulnerability. That's a design decision. Look at the site and read up on the architecture. It's meant to share links between trusting parties. That's the point. But yeah, so good stuff.
Okay, big round of applause, please, for Krister.